Okay, calculus people. Everything you're doing today is a mean value theorem problem. Okay, so let me remind you what the mean value theorem says. That says that if we have a function that is continuous on a closed interval and differentiable on the open interval, and if the y values are not the same, right, so here's f of a and this is f of b, then there is some place on your graph where the slope of the tangent line is equal to the slope of the secant line. Okay, so this is what we're trying to find. We're trying to find this point, this x value, which we're calling c, on our graph or on your function, where the derivative, so f prime at c, the instantaneous rate of change, is equal to the average rate of change, which is f of b minus f of a over b minus a. Okay, instantaneous, which is your derivative, equals the average rate of change, which is the slope connecting your 2 points. Okay, so this is just an algebra 1 equation, and this is a calculus derivative. So we're trying to find what point C has the same derivative, has our same slope as your original equation does. Okay, so that's what we're trying to find in each of these problems. So let's start with number 10. It looks much more interesting. On -1 to +1, well, it is a cubic, which means it's continuous. Okay? And because it's a cubic, it's going to be differentiable on all of your values, right? There's no cusps on a cubic. There's no vertical tangent lines on a cubic. So the two stipulations of the mean value theorem are true. So what we're going to do is we need to calculate what is f at -1 and what's f of 1. Okay? Because we're looking for the derivative at some point c equals f of 1 minus f of -1 over 1 minus -1. Right? So that's our a and our b. This is the a value, right? The left end point of our interval. And this is the b value. So there's our f of b. There's our f of a. Here's b minus a. Okay? And eventually, we're going to take the derivative of this and put it over on the left side. So we're going to spend a minute to calculate what is the y value when x is 1 and what is the y value when x is -1. So we find that our left endpoint is 0 and our right endpoint is -2. Okay, so now let's do the rest of our math. We're going to take the derivative of our function, and I'm going to change the x variable to c. Right, I'm looking for some c value, so I'm going to change the x variable to c as I take the derivative. Okay, so follow me here. So x cubed is 3x squared, but I'm changing x to c, remember, minus 2c minus 2. So that's the derivative of x cubed minus x squared minus 2x, where I'm replacing x with c. Okay, and that equals f of b, which was -2, minus f of a, which is 0, over 1 minus -1, which is 1 plus 1. Okay, so in my numerator, I have -2. In my denominator, I have +2, so I have a slope of -1. So now I want to solve this equation, 3c squared minus 2c minus 2 equals -1. Okay, that is my job now, is to solve that equation for c, and I'm only going to pick the answer that's going to be in my interval from -1 to 1. So maybe I'm going to get a 3 as an answer. That would not be viable because that's not in my interval. I'm looking just the interval from -1 to 1. Okay, so let's come over here and solve this. 3c squared minus 2c minus 2 equals -1. Okay, so I'm going to add 1 to both sides so I can make this into a quadratic. 3c squared minus 2c minus 1 equals 0. So let's factor this. Hopefully it's factorable. I have 3c and c. That's what multiplies together to give me 3c squared, right? So I have a 3c times c. That's a c squared. And now I need numbers that multiply to give me -1, which are, of course, 1 and -1. So the question is, which one goes where? So let me test, just to test, what if I put a +1 here and a -1 there? Now when I FOIL this, I'm going to get a positive 3c minus 1c, which gives me a positive 2. So clearly, these are the wrong signs, right? My signs are in the wrong place, because I want to have a minus in the middle. So this needs to be a +1 here and a -1 there, so that when I FOIL, 3c times -1 is -3, plus 1, -3 plus 1 is -2. Okay. So when I solve both of these, I get -1/3 and I get +1. Okay, so then my answer is going to be -1/3, because that is the number that is on my open interval from -1 to 1. Okay, so at -1/3, I'm going to have a -1 slope on my graph. Very good. Let's look at this number 12, this square root function. Okay, so on 3 to 7. So notice that this is a graph of a square root function that has been shifted 3 units to the right. 1, 2, 3. Okay, so is our function continuous on 3 to 7? 3, 4, 5, 6, 7. Yes, it is. And is it differentiable on the open interval? Are there any gaps or cusps or anything like that? No, so it's good. We are good to go on the mean value theorem. Okay, so the first 2 things we need to do, we need to calculate the y value at our endpoints, because this is part of your average rate of change, f of b minus f of a. Right, so 7 is your b value, and 3 is your a value in your formula for the mean value theorem, which says the instantaneous rate of change at some point c is equal to the average rate of change on your entire interval. Okay, that is the conclusion of the mean value theorem. Now let's plug in everything we know. So when we simplify this fraction, we get 2 over 4, which reduces to 1/2. Now let's come over here and we're going to take the derivative of square root of x minus 3. So that's our derivative. 1 over 2 times the square root of x minus 3 times 1, of course, because that's the derivative of your guts here, but timesing 1 doesn't change. So look at what we have. Okay, we have 1 over square, or 2, right? We have a fraction here with a 1 on top. And what do we have on this side? A fraction with a 1 on top. So we want this fraction to be equal to that fraction. So check it out. Is the top equal? Yeah, that means the bottom has to be equal also. Okay, if my fractions need to be the exact same, that means this denominator of 2 roots of x minus 3 needs to be equal to just 2. The denominator of my left fraction needs to be equal to the denominator of my right fraction. Now, believe it or not, if I were to cross multiply, right, this times 1 equals that times 1, right, it's the same thing. So if I have a fraction equals a fraction, I solve that by cross multiplying, and I get 2 root x minus 3 equals 2. So what's my next step in solving this equation? Divide by 2, right? Divide by the 2 in front of my root. And I get roots x minus 3 needs to be equal to 1. Okay? Our next step in solving this would be squaring both sides, right? I square to get rid of a square root. What's the square root of 1? Is 1. And then my final step is adding the 3. So x equals 4. Or rather, I guess if we're going to be true to our formula, this should be the letter C, right? All of these should be C's if we're going to be true to f of C. But that's okay. X and C, it's fine. It's fine. It doesn't matter that much. Is this on our interval? Yes, it is. So at an x value of 4, our graph is going to have the same slope as from 0 to 7. Right? That's what we're looking for graphically. Okay, let's look at a trig problem. 2 cosine x plus cosine 2x, right? And I'd like to see this in parentheses so that we don't get confused, but that's okay. It's however it's printed. Okay, so on 0 to pi, we're looking for a point that has a congruent tangent to f of 0 and f of pi. So let's do some unit circle simplification first. So there are our two y values. So now let's write down the conclusion that there is an instantaneous rate of change that is equal to the average rate of change over our interval. Okay, so that's the formula we use for every single one of these MVT mean value theorem problems. Now let's replace what we know. And simplifying this gives me -4 over pi. Okay, which is a perfectly fine answer. In fact, it's a wonderful answer. That's as perfect as it gets. So now, let's take our derivative of our function and plug it in down there. So there is our derivative, -2 sine x minus 2 sine 2x. And we're looking for when is that equal to pi, -4 over pi. Okay, so we're actually going to turn our calculator on for this one so that we can use that as our aid. So I'll be taking pictures of what we put into the calculator. So this is the graph of our derivative. Okay, so we're going to do a couple of things. Number one, we're going to change our zoom to just go from 0 to pi. Okay, because that's all that we're looking for. So we're going to go into menu, window, and we're going to change our window to just be 0 to pi. So there's my zoomed in graph from 0 to pi. Now I'm going to come in and add another graph. I'm going to add y equals -4 over pi, and I'm going to see where they intersect. I'm going to see where they are equal. So let me show you that. So notice our graph, our trig graph intersects our number graph in two places. Okay, so now I'm going to use the functionality of my calculator to find out where those two places intersect, and that's going to be my two answers for this because it crosses, right? I'm looking at my interval from 0 to pi, and I have two places where the graph of -2 sine x minus 2 sine 2x equals -4 over pi. So I'm going to have my calculator help me calculate those. So my calculator tells me that my answers to this, my first C value is 0.217. So that's a decimal. And my second one is at 1.75. Okay, so those are my two answers on the interval from 0 to pi where the derivative is equal to the average rate of change. Okay, and that's what it's all about. Have a swell day.